So I'm Ed. I'm going to talk to you about the beginnings of the EaganMatrix and sort of go over the start of the getting into it a bit. I didn't mind giving up my time because mine's a two-parter, so whatever I kind of miss in this one, I can always catch up on the other part.
Okay, you said you don't mind giving up time. I got to say just a couple sentences about it. I spent decades on this. I was very careful about it. I could tell I was not very musical. I would play for people, and they would say, "I've practiced a lot," but they would say, "Oh, that's what it does." This thing didn't really become a real musical instrument until Ed Eagan. So I'm incredibly.
So my side of that coin is, when I got involved with this, and he was so receptive to my ideas, and this is a real labor of love, but for me it was like, wow, I have all these kind of ideas, and I've got this amazingly intelligent hardware and software designer who will do my whims. So for that, I'm really grateful. So Continuum owners, you'll recognize this. This is the editor, and these are the two main windows that you'd be exposed to, the one on the bottom. And you can use it in different ways. Like the first thing that you can do is you can set it up as a MIDI data router. So it's actually pretty sophisticated. I think the top part you're familiar with because you have to pretty well set that up unless you've already auto-detected your MIDI interface. You maybe don't have to do that. But that bottom part on the right is actually a very interesting data router, so you can control the way the MIDI comes back from external sources to a CBC or back to its output, or the internal DSP. But you can also have the surface data go out to the DSP and or the CBC and or the MIDI output. So in a situation where you're using the Continuum with external synths or a DAW, that can be quite useful. It's also, this editor has a really nice overview of Continuum performance controls, and these are the sort of generic things that are in every single sound, either the specialty sounds or those built-in EaganMatrix sounds. And it's also a nice interface to show you what the internal presets are, what you currently have loaded, and also the preset groups, which is a great way to load up sounds for a performance set. Or I use it when I'm editing, and it's like this big buffer that you can instantly save things, versions in, go back to it and try it. I'm actually kind of surprised, and I've had people that didn't realize that you can just shift-click on one of those user preset areas and save a sound. It was in the manual, but more than one person has, come to me and said, "Oh, I didn't know it could do that." And so, if more than one comes to me, that's a mistake on my part. And this is actually a really useful thing. You can use the editor to display what notes you're playing, their amplitude, the Z value, where they are in the Y direction, and really importantly, the X direction with the pitch. And we sort of came, and this is actually the display, it's getting its information because this is just there's no sound generation in here. What happens is you play the Continuum, that MIDI data goes into the editor, and then it goes back, it goes from there back into this display through the MIDI port. So all that display information is based completely on the MIDI information that the Continuum is putting out. And the circle, what we did was, like, there's three different directions. There's very, very, very accurate X direction. So you needed something to have a micro tuning indication. So the vertical line inside the circle became a really nice way to show that. And then the circle was really nice to show the Z value, because that was it showed you a nice relative changes between a small circle and a large circle. And it was also useful to see what MIDI channels you're on. Those are the numbers that are on the top of that display. But the Y was an interesting thing, and in the development of the Y direction, just because of the mechanical design, the way that the Hall effect sensors are, and we're rocking these rods back and forth, the Y just isn't nearly as accurate. And so we, with Lippold, we ended up trying to think about this Y direction, what we can do with it. It's kind of weird because you're looking at this thing, you're starting to design sounds, and you're saying, well, it's not really accurate, but I'm doing musical things with it. I mean, it seems like a very musical thing. And so we had a kind of a choice between erring on making it more absolutely accurate or making it more relatively accurate. And I thought, and I think I'm right, like the Y direction really benefits from being relatively accurate. And it really ties into the way you play an instrument. You happen to hit the string on the, and you realize just from playing it very quickly, you bowed a little too soft, so you dig in right away. So that's a relative action from the audio feedback that you're getting. So that's where Y really comes in nicely. And I use it all the time in the sound design. So there's the bidirectional connection that you get with the Continuum. And we've set up auto detecting for the iConnect Mio, and also earlier on with the what's it called, the MIDI mate? ESI MIDI mate.
If you have an ESI MIDI mate, write me email. Unfortunately, I already gave them all away. If you still have one, write me email and I'll send you a Mio. Give me your address and I'll send you one. The MIDI mates tend to die after some amount of time because they overheat. And the Mio looks less cool and is very reliable. So get the cool and reliable. Less cool.
Did you give me the Mio?
Yeah. I think so.
Actually, that company iConnect is very cool. They do some really nice interfaces.
Yeah, it's just because they're Canadian.
Yeah. So developed in Max, which I have my experience in programming was at university taking a first-year course and bringing my stack of cards down to the center where I could run the program, and then you would get an output and go through that. So I've always been interested in it, and always been interested in math, but the programming it's just daunting. And at one point I said, hey, Lippold, should I really learn C++ or get into this? And he said, why would you do that? Well, there's millions and millions of people that do code, and it's like he wanted to harvest my abilities as a sound designer. So it was very selfish on his part. So anyway, did it in Max, and Max is really cool because it's oh, you're not going to see that stuff. I can't move it up, but what's nice about it for us, it's instantly cross-platform. So whatever I do here, I can send in these files called MaxPath files, and Lippold, who works in Windows, can do a build. So it's completely cross-platform, and so the responsibilities of working in Windows or in a Mac OS is completely in Cycling 74's hands. So we're kind of at their mercy, but they've done such a tremendous job in supporting it. And it's a really, if you want to get into it, I hardly recommend it because there's so many predefined things in there. There's great tutorials. There's a lot of things that I learned going through there, and they have this built-in help structure that's just amazing. So you go and you've got one of their widgets open, you do a Command-Shift-H for help, and this window comes up with a working example, and then working things that, hey, maybe you could try this, you could try this, and try this, and then and that's built in Max, so you can take that, pull that code out, and just bring it right down into your into the GUI environment that Max is based in. So I really like it. Okay, so this is where you open up the EaganMatrix area. And also, just to the right of where that little triangle is, you can do Command L, it'll open up that bottom window. There's an overload protector there. We were talking about this situation. And so this is whenever you open that up, that overload protector automatically comes on. So we designed it this way because if you're in a performance mode and you have a sound up there, you can actually have a transient that is so loud it's going to go through the full range. It's going to go past 0 in the D to A, but musically it doesn't matter. You know, you don't really hear it, it's so brief. But what the overload protector would do is it'll shut the whole system down. And so you don't want that to happen live. So we've made it as an option. But just as a safety feature, when you open up the editor, it assumes you want to edit something and it turns on the overload protect. Even in spite of that, this system is, you know, it's kind of a live, really dynamic system. So you have to start to, when you get into programming, get into the idea that you're very, very careful. And if there's something you don't understand, the first thing you do is turn the gain knob down. So you just, you know, protect yourself. And that particular spiral that Lippo was talking about, that was actually just, you know, a bug that came in. So it wasn't something I was particularly doing, but it's still, in spite of the overload, it gave my ears a good ringing. There's the EaganMatrix area. It's basically a big patching system. You have here, it uses this metaphor for patching instead of using anything like pop-up structures or a GUI or a predefined signal flow type of structure. It's very, you know, it's very, very compact. That's why I like it. So you can really get an overview and see the entire sound structure at a glance. Here's the main part, the matrix. This is where you're going to place formulas, numbers, and those are going to be the routing connections between the sources and destinations. And this is the formula area. So what this does is it displays the structure of the particular formula that you've highlighted. So if you look at these arrows from the source and destination and it's highlighting the J, we can see the structure for the J formula below it. So if you were to change it and go to G, it would then show you the G formula. Or you can actually change them manually by using thumbnails, which are over here. And this, you can think of this as like a shorthand to show you every single formula that you're working with. And it's not very much information, but it's tremendously useful information because at a glance you can decide, you can look at it and say, I want to see every single formula that's got Y influence in it. Like, am I using Y? Or I want to see every single formula that's using shape generator 3, or every single formula that's connected to barrel 4. So at a glance you can go through and see every single one of those formulas and decide where you want to work on, and if you change something, you know, then it'll have influences on other areas of your structure. So when you look at those thumbnails over there, you can see certain parts are grayed out and certain parts are blue. And so the grayed out means it's inactive, and the blue means it is active. So in this particular sound, which I don't even remember what it was, I can see, for instance, that...
looking at it?
Huh?
You can't read the matrix?
Yeah, it's a sine wave. That's a simple sine wave. Yeah, formula D is the only one using Y. So I could visit that and say, okay, well, what was what was the reason? Why did I go into that sort of thing? Okay, thumbnails. It was really nice, and so it shows you every single formula. We have 8 of these, so that's 20 formulas that are available, which, you know, can sound like not very many, but in actual fact, it's very rare. You have to try really hard to overload the structure, and if you are overloading it, then perhaps there's something wrong with your design.
Well, actually, you know, that's a fair concern. In a lot of synthesis nowadays, people add more and more layers if they're unhappy with their sound. And you really don't want to do that here. You know, the other thing to mention about the formulas is that they can appear, a single formula can appear many places in the matrix, or sometimes formulas are just modulating other formulas. But
that's a huge thing.
It goes a long way. Plus, there's also constants in the matrix and some predefined formulas.
Can you give some examples of these formulas? Are they like nonlinear transfer functions?
They are.
And
yeah, that's more for part 2 when I get into the formula. And actually, if I go through this, because I don't know, the first keynote thing I've ever done. So if I have time at the end, I'll start going into the form. That's where I was going to end off, like
Okay.
not getting into that. But you can sort of see it at the bottom, like Formula J. It's again the same paradigm here. We have X and Z are active, and just to look at it quickly, I can see
It's blue.
it's blue, so that means it's active. I'm not using a gated signal, which is the W.
Looks like a constant.
Pardon me?
It looks like a constant. Is that what Z is there?
Z is a constant.
Okay.
So it's just a lazy, it's just to say, hey, I wanted a 0.5 value whenever this formula went on. So this formula is more about what's happening in the X direction. So here we have a 0 value at E5, and as you go up from there, every octave it's going to subtract 0.01 from that numerical value.
So you're squeezing the notes, right?
Yeah, so you could think about it at E5, this formula is outputting a 0.5, and then if I go up to E6, it's now a 0.49.
Uh-huh.
Yeah, that way.
So you can squeeze like pianos are squeezed and stuff like that.
So it's all very flexible.
Yeah.
Yeah. And these formulas, they can appear at a matrix point, and they can be linked together. They can be a whole series of mathematical connections between them.
Mm.
But that really is part 2.
Mm.
This formula idea was really distilled from my experience with using the continuum and these kind of like prototype building blocks that I was always doing in Kamaa. And so in Kamaa, I was always saying, geez, I always seem to be using a squared function on the Z output, and I have certain things that I always want to do and certain ways of combining it. And so after, when we started develop the specialty sounds were prototyped in Kamaa, and then because of Lippol's low-level knowledge of and his involvement with the symbolic sound product, that we just reversed engineers things. And then, so it was back and forth. Eventually, there's just too much of a window where he would give me something and then we would code in some values and say, well, we use this dial to change and see what you like over there. It was really a long process, and we realized.
Yeah, I mean, I don't work for symbolic sound, and actually, I only know some things about it,
Yeah.
but mostly the process was one of rapid prototyping. Kamaa's fantastic,
Yeah.
because there's all sorts of capabilities. But then, he sends me a Kamaa sound, and while I could look in Kamaa, I don't know anything, the details of what that is, so I tried to do the same thing, and it was always sort of disappointing because he really perfected it in Kamaa, and I didn't get exactly the same thing. So it was a difficult process. It was rapid prototyping, but not exact prototyping because,
Yeah.
I just tell people too, if you want to use Kamaa, just stay in Kamaa. It really works. It has a lot of capabilities, and to try to port to another system and then say, oh, it's the same thing, I think is a bit of a pipe dream.
And not only that, fixed point versus floating point,
Oh.
which was a real big deal for some of these biquad filters that we have where the energy can go off the roof. There were certain things I could do in Kamaa and you would just hit walls, whereas with this floating point system, it was just, and we were realizing we're hampering ourselves. One thing.
But just to be fair to Kamaa, right? There's many things Kamaa can do that this doesn't.
Yes, yeah.
So this is
Yeah.
this is all the stuff that you can do on chip in a Shark.
It's more of a comparison of, like, if you're trying to prototype there, between that type of chip and the Shark. I don't know what they have, their DSP in there, but
Freescale.
yeah. So there's so many differences in time things. We needed to develop our own synthesizer. One paradigm to look at, you see colors mainly. There's red things, there's blue things. Blue things mean this is something that can change. It'll report. It's a display system. Shows you something's active or there's a numerical. Anything that's red is something that you can interact with, and so it's good. So you might notice when you look at this, the routing over here, we have sources on this side, and there's certain sources there you see are in red. Well, that means you can click on that, and you can get a pop-up menu, and then you can go to, and you can use those two source rows for something different that's in that pop-up. And it's the same thing on the destinations up here, where any red thing, these means there's a variety of modules and things that you can access. So again, like sources on the left, destinations on the right. And that signal flow is showing you, whenever you click, you're going to get those nice blue lines and showing you where you're editing and where the source and destination is.
And then, does that represent just
Yeah.
the limitation of screen real estate, or does it represent DSP limitation?
DSP.
Yeah.
Yeah,
that's what I'm
yeah.
Yeah, exactly, yeah. Well, just-
Oh, this is the boy, yeah. Yeah, so I studied at Carleton University in Ottawa, and because the head of the department was from England, we had close to, he bought EMS stuff, not east or west coast, but other side of the pond. And they had a Synthi 100 in this room and a Putney. Honestly, I rarely touched the Putney, and the Putney was very handy because it had this nice vinyl cover on it, and it was great for holding your music as you worked on the Synthi. It's such a shame, but and there's a whole long story. I eventually ended up being the caretaker for this Putney and saved it from being stolen. Sent it to a wonderful tech in Calgary who recapped it, and so I put the bill. I think he did all sorts of stuff, cleaned it up, got it working in great shape. Talked to Robin Wood at EMS. Who's still making these things, but you'll have to wait a long. I was just reading one time. One guy waited 12 years for his EC3, but you know he's doing it for the love of it. He's not, you know, and they're beautiful. They're quite interesting, and so he sent me more pins because they had run out of pins, and so I think the bill for the whole fix up was $600, and I got to have the thing for 6 years. So for me, it's a really cool synthesizer. So I really liked it. So there's the matrix there. You can see they have their sources on the left and destinations on the right. And I've always loved that word treatment. That's just a great.
On the top.
Oh, I'm sorry, on the top. Yeah. And it's a matrix.
Did yours have resistor pins or diode pins? Because the resistors would drop voltages.
Yes, yeah, it was resistor, and that was interesting. That was, you know, part of the charm.
Yeah,
I think.
exactly.
Yeah. Okay, what do I got? Oh, 4 minutes. Okay. Yeah, so matrices in an analog system, they're really nice, concise way of patching. They have big drawbacks. It's a wiring nightmare because as you have your modules up above, every single line has to come down for the sources and destinations. So, you know, you just end up with all this. So you can get crosstalk. Also, the design in the EMS wasn't buffered. So as you push, you know, a pin in, it would just have this cross. You think you're patching this way, but electrically you're actually patching back too. Things would go through. So you could change tuning, and it was unstable. But it had so much character. And actually, an interesting thing for me, it was like an acoustic instrument because it had a built-in spring reverb and built-in speakers. So wherever you went, you could just play it and work with it. And you could get the spring reverb, the feedback. Okay, and non-buffered. Okay, so let's look at this patch and see how this translates. The yellow pins, it's taking the filter output and feeding it into the output channels. And then in this red pin, what we're going to do is modulate the frequency of the filter with the square wave from oscillator 3, which is typically, it's a low frequency oscillator. So in EaganMatrix, here's the same structure. Not the same sound, but. So here we have oscillator 1. You can see this oscillator filter. These are selectables as oscillators or filters. It's going into the audio input on the low pass filter. And then here, the yellow pins, but here there's the output from that filter, which is oscillator filter 4. See the number before on the 4? It's going into the main inputs on the master section. And then we're going to modulate the frequency of that low pass filter with the LFO number 3.
Is
Oscillator 3.
SLSR sound left, sound right?
Submix left and right.
Okay.
Yeah, so there's a whole, you see the chain where it goes SLSR and then it goes through CN1, rec.
Yep.
That's the whole processing chain.
Yep.
So you add your reverb and convolution bodies through there. If you don't want it, you see the mix control, the M below the 2 arrows, that's a mix. And so if I had fed the 1 and 1 into the L and R on that side, if you put a value of 0 to 1 in that mix control, that will control the mix between the processed sound through the master section or the dry sound.
Where is the gain control in that signature?
You see the line, the blue line that's going to the word master?
Yeah.
Okay, and it's going up, and there you have a master gain just above that. So
it's right at the end.
Yeah, that's right at the end, yeah.
So actually, often the gain that you want to use is much earlier, because within this master there's a lot of stuff, but one of the things is there's either soft clipping or wave shaping, and a lot of people will drive those hard just to get that kind of fun.
Yeah. So you can feed a low-level signal into the SLSR, turn up the gain, and you'll avoid the saturation, or you feed a lot of signal in, turn down the gain, and you can saturate the output if you want. Okay, but anyway, there was ones in all those things, and that's the same thing as a pin. You're just shorting that connection. But here's, I'm just going to cover this slide. I'm right at 11:59 now. This is what really makes it powerful. Lippold alluded to this. You have these dynamic pins. So you don't see any representation of the continuum surface there. Though that representation is built into the formula. So if you can think about it, when you put a formula number letter in there, it is a representation of every single finger and every single variance of X, Y, and Z. Let's see, yeah. And they can be, these pins can either be constants, so they can be numbers, or they can be decimal values, and there's quite a large range there. There's even a wider range of discrete numbers you can put in by using multipliers. And every formula is a surface interaction. Okay, so...
Those were the ones at the bottom, primarily?
That's right, yeah,
Okay.
yeah. Okay, so that's my time. And I could stop here. It's a good place to stop. Any questions at this point, or? We're good? Yeah, go ahead.
When you were talking about the thing with the gain, you know, up or down to whether it gets clipped or saturated or something like
Right.
that, is that on, if you're playing polyphonically, is that on?
Yeah, it's a master
visual?
effect.
Or it's a master?
Yeah, it's a master effect.
So you would actually get, like, if you were playing a third or something and you did that a lot?
Absolutely.
Yeah.
There's a way to do that on a note-per-note basis by doing wave shaping.
Okay.
But yeah, we can get into that.
More questions?